It's called 3I divided by Atlas, the third object from outside the solar system. But there's something about it. It's unlike any comet we've ever seen. On October 3, several orbiters around Mars captured images of the object's closest approach to the red planet. The European Space Agency released the image 4 days later, a fuzzy white dot, 30 million kilometers away. They say that's the limit of the instrument because it was designed to study Mars geology, not to track an interstellar visitor. Leave a like and subscribe so you don't miss the next one. But there's something they don't tell you. That same day, NASA's Mars Reconnaissance Orbiter was in perfect viewing position. The high-res camera on board was able to distinguish an object the size of a kitchen table on the surface of Mars from orbit. At 30 million kilometers, it was perfectly capable of taking 3I Atlas images with a resolution of 30 kilometers, 10 times better than the European images released. Those images exist. They have been taken. But as of today, October 19, they have not been released. The official reason: the US government shutdown. 15,000 NASA employees are furloughed. Website updates have stopped. Communications have been paralyzed. Just when the world needs clarity most. The European Space Agency is not affected. China is not. The UAE is not. All have tracking ships. All are strangely silent about the highest resolution data. The 1st of July 2025, the Atlas Survey Telescope in Chile spotted a moving object in the constellation Sagittarius. Nothing unusual. Atlas detects asteroids all the time. That's what it's supposed to do. But just a few hours later, the preliminary trajectory stopped astronomers in their tracks. Too fast, too straight, unlike anything they'd ever seen. The object was traveling 58 kilometers per second relative to the Sunday, twice the escape velocity of the solar system. It couldn't be an asteroid from the belt between Mars and Jupiter. It couldn't be a comet deflected from the Oort cloud. It came from elsewhere. July 2, Minor Planet Center confirmed. 3I Atlas. The I stands for interstellar, the third visitor to pass through the solar system after Oumuamua and Borisov in 2019. Both of the previous visitors had hyperbolic orbits and unnatural speeds. By Atlas differs in one crucial way. Oumuamua came from above, tilted 123 degrees to the ecliptic. Borisov is tilted 44 degrees. Coincidentally, as expected, for an object ejected from a distant star system, 3 Atlas arrived at an inclination of 4.89 degrees. Almost exactly on the ecliptic, where Earth, Mars, Venus, and Jupiter all orbit. The chance of this coincidence happening by chance, 0.2%. That's 1 inch 500, and that's just the beginning. When astronomers traced its trajectory, they found it came from the direction of Sagittarius, but not just any part, but from the center of the Milky Way, the densest part of the sky. a region where detecting a faint object before July 2025 would be nearly impossible. It was as if it knew exactly when it would be most difficult to detect to appear. If you have your own theory about why it chose this direction, leave a comment below, because sometimes the most interesting answers come not from the lab, but from people who are still listening. 3I Atlas will reach perihelion on the 29th of October 2025. Only 10 days to go. It will then be 1.36 AU from the Sun within the orbit of Mars, traveling at 68 kilometers per second. And here's the important detail, the one that made Harvard professor Avi Loeb wake up at 3 a.m. to do the calculations on a napkin. 3I Atlas will be on the opposite side of the Sun from Earth, at perihelion, completely hidden from all ground-based telescopes. At the exact moment when it is brightest, most active, and most likely to reveal its secrets. If someone wanted to design an interstellar probe and do something that no one else could see, they couldn't have picked a more perfect time. A true comet is made up of water ice, CO2, methane, ammonia, silicate dust, and trace organic compounds, remnants of star formation. As it approaches the Sun, the ice sublimates into gas, dragging dust along to form comas and tails. It's simple and predictable chemistry. We've analyzed dozens of comets in the solar system and 2 interstellar comets before. The ratios vary, but always follow a pattern. Water dominates. 3I Atlas breaks that pattern completely. August 2025. The James Webb Space Telescope points an infrared spectrometer at the object. JWST is very sensitive to identifying molecules through their emission spectra. The results are unprecedented. 87% of the object's emissions are CO2. Water is only 4%. Typical comets are 80% water. CO2 is only 10–20%. The ratio is completely reversed. It's like finding a human body that is 87% bone and 4% water. Then there's the nickel issue. August 21. The Very Large Telescope in Chile detected atomic nickel vapor in 3I Atlas's coma. This has been seen before in other comets, but always in similar concentrations with iron, because the two are born together in supernovae. They always travel together in interstellar space. They occur together in rocky bodies. But in 3I Atlas, iron is absent, or at least undetectable. The ratio of nickel to iron is extremely skewed, approaching that of industrial alloys, the kind of ratios used to make heat shields for spacecraft, not those that form naturally in the solar system. Some astronomers think this could point to a very different formation environment, a star system with an unusual metallic composition, a protoplanetary disk with unexplained chemical separations. Others note that nickel-iron alloys are exactly what you would choose if you needed to build an object that could withstand the extreme thermal changes and high-speed particle collisions of interstellar travel. The data are vague, but the implications are not. And then there is the temperature paradox. 3I Atlas is ejecting gas in huge quantities. The outgassing rate measured in August 2025 shows it is ejecting more than 100 kilograms of matter per second. That level of sublimation requires a huge heat source. Solar radiation hitting the comet's surface should heat it enough for ice to turn to gas. But infrared observations show the object is still very cold, much colder than it should be. At this distance, and with such intense activity, it's like watching someone sweat in a freezing room. The physics don't add up. One explanation: the object has a low thermal lag. The illuminated side heats up quickly and radiates heat quickly, keeping the average temperature low in the eye of the measuring device. Another explanation: the outgassing isn't driven by sunlight at all. There's another source of energy that's driving this activity. An internal heat source. A mechanism we don't have a name for. The scientific papers are very cautious. They note anomalies. They suggest further observations. They avoid guesswork. But in closed-door meetings and internal emails, astronomers use a different word: unusual, in the sense of not fitting any natural model we have today. Let's talk about what happened on the 3rd of October 2025. 7 probes from 4 different space agencies were positioned to observe 3I Atlas as it made its closest approach to Mars. This was the best chance to get detailed images. The Mars orbit put the entire fleet between Earth and the comet, providing views that were impossible from the ground. ESA's TGO, ESA's Mars Express, NASA's Mars Reconnaissance Orbiter and MAVEN, China's Tianwen-1, the UAE's Hope, and from the surface, NASA's Perseverance rover. Plans were submitted months in advance. Observation windows were calculated precisely. Instruments paramétrés optimized. Everything was ready. Then the images started pouring in. On October 7, ESA released their images. TGO captured 3I Atlas as a dim blip moving through the starry background. The exposure time was 5 seconds. The maximum the SASIS camera can handle without being blinded by the background stars. The result: a halo with no discernible core, no structural detail, something a good amateur telescope on Earth could capture. The ESA press release was almost apologetic. This was an extremely challenging observation for the instrument. Comets are 10,000 to 100,000 times dimmer than typical targets. The camera was built to capture bright Martian cliffs at 400 kilometers, not a strange visitor at 30 million kilometers. Not all instruments are suitable for all missions, but NASA's Mars Reconnaissance Orbiter is a different story. The HiRISE camera on MRO is the most powerful observation ever sent to another planet. Its angular resolution is enough to see a 30 centimeters object on the surface of Mars from an orbit of 300 kilometers. At a distance of 30 million kilometers from 3I Atlas, HiRISE has a resolution of about 30 kilometers per pixel, 10 times better than ESA, 10 times more detail, 10 times more data. If there is structure, if there is an unusual geometry, if there is something wrong with the natural comet, HiRISE should see it. And the images were taken. The observation window was set. The probe was in position. The data was collected and transmitted back to Earth. By October 19, 8 days later, the images had still not been released. NASA's official statement: the government was shut down. Over 15,000 employees were furloughed. The website was frozen. No one was processing the data. No one was writing the press releases. A plausible reason for delaying the release of non-urgent data, except 3 things. 1. The shutdown began after the images were taken. October 1 was the shutdown date. October 3 was the image capture date. NASA had 48 hours with full staff to process and release the important scientific data. 2. ESA released the images on October 7th. They have nothing to do with American politics. They release what they can in a few days. NASA could do the same. 3. And most importantly, other agencies don't release their best data either. China's Tianwen-1 has a pretty good orbital camera. In place, no photos, no announcements, absolute silence. The UAE's Hope has a science camera that captures the atmosphere and surface of Mars in detail, also in the right place, also silent. Multiple space agencies, multiple sovereign governments, multiple bureaucracies, multiple political systems, all simultaneously withholding data on the most remarkable object to pass through the solar system in years. This common denominator is too hard to dismiss as coincidence. You can't accidentally coordinate silence. You only coordinate silence when you all see the same thing and no one knows how to explain it. On October 3, the day of the Mars flyby, a Portuguese amateur astronomer using the name Dobsonian Power posted a photo to Reddit that immediately went viral. He tracked 3I Atlas with a solar telescope, not ideal for faint objects in deep space, but still workable with heavy digital enhancement. The image revealed something surprising in 3I Atlas's diffuse halo: appearing angular structures, geometric dark shapes, irregular protrusions that didn't fit the symmetrical diffusion pattern of comet dust. The caption was simply, "What the hell is this?" Within 6 hours, the post had spread across every major astronomy forum and subreddit. The reaction splits into 2 camps. One group sees evidence of artificial structures, arguing that 3I Atlas is not a natural comet. Some suggest a cylindrical object, others that it is an asteroid with traces of manufacture. Some go further: spy technology or a warning beacon from deep space. The other group dismisses it, calling it pareidolia, the human tendency to see patterns where none exist, amplified by inappropriate equipment and overprocessing. The sunglass uses a powerful filter for bright light, pointing it at a dim comet millions of kilometers away. Is like using a welding mask as binoculars. You are forcing the device to do something it was not designed to do. Add in aggressive digital enhancements, and you are asking an algorithm to make up details that are not there. But Dobsonian Power is no amateur nonsense. His YouTube channel has been documenting serious astrophotography for more than a decade. His equipment is clear, his methods are careful, his image processing is transparent. He knows his limits. When challenged about unusual structures, he doesn't push back. He admits he's not sure and promises to look again when 3I Atlas exits the sun in December. His response is scientific and cautious, but that's exactly what makes the mass denial campaign that followed all the more suspicious. Within 24 hours, several astronomy sites published articles that directly targeted the image. Amateur telescope takes bizarre 3I Atlas image. Why? It's not what you think. The timing of the post seems intentional. The tone is defensive, as if someone needed to quickly confirm that there was nothing unusual before the image went too far. Then the enhanced war began. Users on Reddit, Twitter, and forum downloaded the original ESA image, then ran it through a myriad of processing algorithms. Some used astrometric image stacking techniques. Some used AI upscaling to increase resolution. Some went full-on with machine learning models to reconstruct details from limited data. The results were chaotic. Some images were only slightly clearer, still blurry. Some showed clear geometric patterns, sharp edges, unusually regular structures. On October 4, an anonymous post appeared on 4chan's paranormal forum. The title was short, ESA Data Leak. The post began with a claim specific enough to sound credible, but vague enough to remain anonymous. I am a PhD student working with the European Space Agency with ongoing access to the combined observational dataset of 3I Atlas. Online leaks are common, but this one is different. The level of technical detail is unsettling. The posters are not extolling aliens, not talking about glowing craft or mysterious signals. Instead, they list a series of specific observational anomalies that, if true, would fundamentally challenge our understanding of what 3I Atlas really is. According to the post, spectral analysis shows that 3I Atlas is emitting about 100 kilograms of nickel gas per second, but there is almost no iron emission. In standard stellar and planetary chemistry, nickel and iron are inseparable twins. They are born together in supernova explosions, travel together through interstellar space, and occur together in comets and asteroids. Finding abundant nickel with almost no iron is like finding smoke without fire. It violates basic assumptions about how matter behaves in the natural cosmic environment. From published observations with the VLT, we know the nickel emission is real. The post is right on this point. What is unclear is whether the absence of iron is a measurement error or a genuine anomaly. Anomaly 2. Thermal inconsistency. The object is ejecting large amounts of gas and dust, the hallmark of an active comet heated by the sun, but infrared observations show it is still cold, much colder than it should be, given the outgassing rate and distance from the sunday. The poster compares this phenomenon to watching someone sweat in a freezer. The physics doesn't match the observations. Again, scientific papers have documented thermal anomalies. The poster is describing real data. The article reiterates what Professor Avi Loeb has already stated publicly. 3I Atlas entered with an orbital inclination of just 4.89 degrees to the Earth's ecliptic plane, but the poster adds something that Loeb has not emphasized. The orbit is not just unusual, it is a perfectly straight shot from the center of the Milky Way. No wobble, no yaw, no sign of gravitational disturbances from neighboring stars over millions or billions of years of traversing interstellar space. As if it were pre-aimed, then the article moves the story from interesting speculation to something more somber. The poster claims the object fits the profile of what they call a post-biological entity, not a natural comet. nor a conventional spacecraft, but something in between. They describe it as having a three-phase particle engine with a power of about 75 megawatts, continuously transmitting an active signal and, they say, probing our solar system. The article reiterates what Professor Avi Loeb has already stated publicly. 3. I-Atlas entered with an orbital inclination of just 4.89 degrees to the Earth's ecliptic plane, but the poster adds something that Loeb has not emphasized. The orbit is not just unusual, it is a perfectly straight shot from the center of the Milky Way. No wobble, no yaw, no sign of gravitational disturbances from neighboring stars over millions or billions of years of traversing interstellar space, as if it were pre-aimed. Then the article moves the story from interesting speculation to something more somber. The poster claims the object fits the profile of what they call a post-biological entity, not a natural comet, nor a conventional spacecraft, but something in between. They describe it as having a three-phase particle engine with a power of about 75 megawatts, continuously transmitting an active signal and, they say, probing our solar system. The post ends with a theoretical framework. The poster suggests that 3I Atlas could be a macroscopic quantum object, specifically something called a cue ball, a strange structure in particle physics, a non-topological soliton, which could theoretically exist on scales larger than subatomic particles. If stable, a cue ball could have properties that seem impossible according to conventional physics, being extremely dense, yet still appearing diffuse, absorbing and distributing energy instantaneously throughout the structure, explaining thermal inconsistencies, and even nickel without iron. If its internal quantum state favors certain isotopes. Within hours, the post was screenshotted and spread across Reddit, Twitter, and UFO forums. The r divided by conspiracy thread reached over 2,000 comments before being locked for violating the unverified claims policy. But locking the thread didn't stop the conversation. It just broke into dozens of parallel threads, each pulling the original post in a different direction. One group focused on chemical anomalies, another group focused on the cue ball hypothesis. Some began to connect old claims that 3I Atlas might be related to the 1977 WOW signal. What made this leak remarkable was, it wasn't wrong about the chemistry. Nickel was actually detected. The thermal anomaly was recorded. Orbital alignment was extremely low probability. Either this is a work of incredibly well-researched fiction, or someone with access to unpublished data has decided the public deserves to know what space agencies are seeing but not telling. The cue ball hypothesis lies on the fringes of theoretical physics. Postbiotic entities sound like speculative exobiology, but the observational data that underpins those interpretations are real. And that's the annoying part. When conspiracy theories are true on the ground facts, it becomes much harder to dismiss interpretations built on those same facts. On October 4, something appeared in the sky above Mars. Something that should not have been possible. NASA's Perseverance rover, which is in Jezero Crater, took a picture with its right-facing camera. The raw image shows a long streak of light, 4 times as long as it is wide, moving against a background of stars. At first glance, it looks like a long exposure image of a moving object. Comets or asteroids are often blurred if the camera follows the stars instead of the object itself. This is normal, but when people started calculating the apparent size based on Perseverance's known camera parameters and the distance to 3I Atlas at that time, they came up with a worrying number: 50,000 kilometers in length. It wasn't a comet nucleus. It wasn't even a comet with a tail. It was something else entirely. To put this in perspective, the diameter of the Earth is less than 13,000 kilometers. If this bright spot reflects the true size of 3I Atlas, we are looking at an object nearly 4 times the size of our planet. Social media exploded. Was 3I Atlas actually a giant cylindrical structure? Was it hiding its true size and shape behind a diffuse cloud of gas and dust? The timing of the image was also notable. It was posted just a day after the Mars flyby, just as professional space agencies were strangely silent. The speculation spread so far that Representative Anna Paulina Luna, a prominent member of Congress with an interest in unexplained aeronautical phenomena, contacted Professor Avi Loeb directly for analysis. Think about it. A sitting House member felt compelled to ask a Harvard physicist about a photo taken from Mars. That's not normal procedure. It suggests that someone in official channels was concerned enough to want expert interpretation outside of NASA's standard communications lines. Loeb's response was detailed and reassuring on the surface. He calculated that Perseverance's navigation camera had an angular resolution of about 0.33 milliradians per pixel. At the distance from 3I Atlas when the image was taken, approximately 38 million kilometers. That translates to about 12,500 kilometers per pixel. The streak is about 4 pixels long, giving it a figure of 50,000 kilometers. But Loeb argues that it is an artifact of synthetic imaging. The streak does not show the true size of 3I Atlas. It represents the path the object traced across the Martian sky over a long integration time, likely about 10 minutes of stacked exposure. His argument is sound. Mars orbits the Sun at 24 kilometers per second. 3I Atlas flies 67 kilometers per second relative to the Sun in the opposite direction, giving a relative velocity of over 90 kilometers per second. In 10 minutes, the distance traveled is 54,000 kilometers, perfectly matching the length of the observed track. The shape is not the object. It is the motion of the object blurred over time. So there you have it, right? The giant cylinder theory is disproved by basic physics and neat math, except for one detail. Loeb inserts a sentence that conspiracy theorists cling to like a lifeline. He writes, "If the NavCam images were single shots with exposure times less than 3.28 seconds, then the brightness and angular length of the observed source imply that it is not 3I Atlas. Then the source could be much closer to the camera, enough to be elongated, with smaller spatial dimensions and lower velocity." If these were single frames, then what Perseverance captured was not 3I Atlas. It was something else closer to Mars. That conditional sentence opens a door that any subsequent refutation cannot completely close, because NASA has not confirmed whether the image is a stack or a single frame. They haven't released the metadata, exposure time, stack frame number, original processing sequence. The official reasons remain: government shutdown, lack of staff to process requests, no one confirming basic technical details about how the image was taken. That leaves us with two possibilities. Either Perseverance took a 10-minute lapse of 3I Atlas's 50,000 kilometers which appears as motion blur, or Perseverance took a closer, slower shot, producing the same apparent length by a different mechanism. Both scenarios fit the math. The observational data is compatible with both. Without metadata, we don't know which is correct, and the longer the metadata goes unreleased, the more people wonder why we don't get to see how the image was made. On the 15th of August, 1977, the Ohio State University Big Ear Radio Telescope was conducting a routine survey of the skies, looking for signs of extraterrestrial intelligence. At 10:16 p.m. Eastern Time, the telescope recorded a 72-second radio burst, so unusual, so structured, that astronomer Jerry Eman circled it on a printout and wrote a single word in red pen: "Wow." Nearly 50 years later, the signal remains one of the greatest mysteries in the search for extraterrestrial intelligence. It came from the direction of the constellation Sagittarius, near its densest concentration of stars. The signal was narrowband, concentrated at just one frequency, and it has never been repeated. Hundreds of follow-up observations followed. Thousands of hours of listening were directed at that same area of the sky. Still zero. Only once, 48 years ago, and then there was silence, until Avi Loeb started doing calculations related to 3I Atlas. He calculated the position of the object on 12 August 1977, just 3 days before the WOW signal was detected. The result: the distance to Earth was 600 astronomical units. That is, 600 times the distance between Earth and the Sunday. It was still in the outer reaches of the solar system, much further than any spacecraft had ever been. More importantly, Loeb calculated the direction 3I Atlas was traveling at that time. Right ascension 1940, declination più 19 degrees. The WOW signal, meanwhile, came from right ascension 1925, declination Mace 27 degrees. The two directions were about 9 degrees apart. In the vastness of the universe, where objects could appear from countless directions, the chance of this coincidence is only about 0.6%. Not impossible, but deeply suspicious. And Loeb didn't stop there. He asked the next question, naturally. If 3I Atlas itself had emitted the WOW signal from 600 AU, how powerful would that transmitter have been? The math was simple. The resulting intensity was between 54 and 212 Jansky, a bandwidth of 10 kilohertzes at 600 AU. That equates to a power output of between 0.5 gigawatt and 2 gigawatts. To put that in perspective, a typical nuclear reactor on Earth generates about 1 gigawatt. That's about the power of a nuclear power plant focused into a narrow beam of radio waves. Nothing is impossible for an advanced civilization. It is even plausible that they would want to send a signal strong enough to penetrate interstellar distances without wasting energy on multi-directional propagation. There is one more detail that makes this connection difficult to reject. The WOW signal was recorded at 4,556 megahertzes, which is blue shifted about 10 kilometers per second toward Earth, relative to the hydrogen reference line. A blue shift means that the source is approaching us. 3I Atlas is currently hurtling toward the Sun at about 60 kilometers per second. Loeb suggests that if the object is maneuverable, it may have slowed down in 1977, then accelerated after the discovery of habitable planets in the solar system. A reconnaissance pulse, a radar scan to check for signs of technological civilization before moving closer. What makes things frustrating is it's incredibly easy to test. Just point a radio telescope at 3I Atlas and listen at the frequency of the hydrogen line. If it's broadcasting, we'll know within hours. If it's silent, the WOW connection may be coincidental. A simple test for a definitive answer. But as Loeb writes in his latest blog post, no radio telescope has reported data on 3I Atlas. The Very Large Array hasn't observed it. Arecibo has been destroyed. Green Bank hasn't announced anything. Even SETI, the organization that exists to hunt for alien signals, hasn't announced it's tracking it. The silence from the radio astronomy community is almost suffocating. Some argue that 3I Atlas is too faint, too far, and too obscured by the background noise of the Milky Way to get any data. But others argue if there's a 0.6% chance of deciphering the most mysterious radio signal in history, and it could be coming from an object right in our own solar system, are a few hours of observation too great a price to pay? Nearly half a century has passed. The signal remains one of the greatest mysteries ever recorded. It came from the direction of the constellation Sagittarius, from the densest region of the Milky Way. A narrow signal, contained in a single frequency, and it has never been repeated again. Since 1977, hundreds of observations have been made. Thousands of hours of listening have been directed at the same region, but the result has been silence. A single sound. Then, for the next 48 years, nothing. If you're listening to Sleepy Science, subscribe to follow along with me on the quiet but mysterious journeys of the universe. Astrophysicist Avi Loeb was the first to tell the story in a different way. He started the calculations related to 3I Atlas, an interstellar object that had passed through the solar system. Loeb realized that on the 12th of August 1977, just 3 days before the WOW signal was received, 3I Atlas would have been about 600 astronomical units from Earth. That's about 600 times the distance from Earth to the Sunday, still in the outer reaches of the solar system, but much farther than any spacecraft had ever been. More importantly, he determined its direction of travel. Ascension 1940. Declination più 19 degrees. The WOW signal came from Ascension 1925. Declination negative 27 degrees. The two directions were only about 9 degrees apart. In the three-dimensional space of the universe, that was a rare coincidence. The probability was only about 0.6%. Loeb didn't stop there. He asked, if 3I Atlas itself had emitted the WOW signal from 600 AU, how much power would it have required? From the recorded intensity of 54 to 212 Janskys, with a bandwidth of 10 kilohertz, he calculated that the output power was equivalent to half a gigawatt to 2 gigawatts, about the size of a nuclear reactor on Earth, a nuclear power plant. But instead of powering a city, it focuses all the energy into a narrow beam of radio waves aimed at Earth. If a civilization wanted to send a signal billions of kilometers away without wasting energy, this would be the most logical way to do it. If you like this slow, warm, and somewhat skeptical science story, subscribe to Sleepy Science. There's another detail that makes this theory harder to disprove. The WOW signal was recorded at 1,420.4556 megahertz. It's blue-shifted by about 10 kilometers per second compared to the standard hydrogen frequency. A blue shift means the source is getting closer to Earth. 3I Atlas is currently moving toward the Sun at about 60 kilometers per second. Loeb suggests that in 1977, the object may have been moving slower and only accelerated after the discovery of planets in the habitable zone of the solar system. A reconnaissance pulse, a radar scan, to see if there are any technological signals coming from Earth. And the interesting thing is, it's incredibly simple to verify. Just point a radio telescope at 3I Atlas Listen to hydrogen frequencies. If it's broadcasting, we'll know within hours. If it's silent, the connection with the WOW signal could be a coincidence. But so far, no observatory has done that. The VLA hasn't observed. Arecibo has been destroyed. Green Bank hasn't released its data. Even SETI, the organization that hunts for alien signals, hasn't made a statement about 3I Atlas. The silence is almost suffocating. Some scientists think 3I Atlas is too weak, too far away, or is being overshadowed by light from the plane of the Milky Way. But many others disagree. If there's even a 0.6% chance of understanding the most mysterious radio signal in history, and the object is right in our solar system, is a few hours of observation really too much? If you find that question worth pondering, leave a comment. And don't forget to subscribe to Sleepy Science to continue listening to the tiny stories that weave through the vast universe. Not likely, true, but not impossible. The counter-argument is valid. If something walks like a duck, quacks like a duck, swims like a duck, and has duck DNA, at some point, you have to consider the possibility that it actually is a duck. In this case, if an object arrives on an extremely low probability trajectory, has a chemical composition that doesn't fit the natural course, coincides with a mysterious radio signal that went off 48 years ago, and causes multiple agencies to withhold their best imaging data, then it might be time to seriously consider that this is more than just a random chunk of ice and rock. Maybe 3I Atlas is more than just a piece of debris from an alien star system. If you're still listening, subscribe to Sleepy Science. The story is about to get a little more unbelievable. Strange things started happening around October 5th. Users on multiple social media platforms reported that their posts about 3I Atlas were disappearing. Not flagged, not marked as misleading, they just disappeared. One Reddit user said he posted a detailed analysis of chemical anomalies from the supposed ESA leak. The post received hundreds of upvotes and dozens of comments in just 2 hours. Then it disappeared without a trace. No admin notice, no explanation. When he tried to repost, the system rejected it. Shadow banned, no reason given, not even on Twitter. And then it spread. Many other accounts began to notice similar patterns. The Astronomy Vibes account, which was famous for criticizing the ESA image, reported a sharp drop in engagement after October 7. Posts that once reached tens of thousands of people now have only a few hundred views. No warning, no official restriction, just a strange silence from the algorithm. Subtle enough to deny, but strong enough to silence people. The astronomy content creation community is starting to notice this. Videos about 3I Atlas, which used to have hundreds of thousands of views, now have only a fraction. YouTube is also having problems. People posting videos analyzing and questioning 3I Atlas are starting to get demonetization notices. The reasons are varied. Some videos are flagged for discussing sensitive topics. Some videos are considered to be misleading about science. Some videos are labeled ambiguously. The content may not be suitable for all advertisers. The motif becomes clear. You can make a video saying that 3I Atlas is just a normal comet. That's fine. Still make money. Still get promoted. But if you say there are abnormalities worth investigating, suddenly, your video is no longer advertiser-friendly. Facebook goes further. Fact-checkers start labeling 3I Atlas posts aggressively. Posts sharing 4chan leaks are flagged for lack of context. Posts citing Avi Loeb's calculations are flagged as partly false. Fact-checking organizations issue reassuring statements that there is no threat from interstellar comets, that the abnormalities are likely natural. The implication is clear. Don't worry. Don't speculate. Trust the authorities. The strange thing is that it all happened at the same time. Within 48 hours of the ESA releasing the official image, when the public was frustrated by the lack of real data. This is the kind of pattern that makes conspiracy theorists feel validated and makes skeptics shake their heads. Because yes, social media platforms often stifle content. Algorithms change. Interactions fluctuate. Fact checks are applied. That's normal, not evidence of coordinated censorship, unless it all happened at once, targeted on a single topic, at the exact moment when the public was most interested and when official answers were most absent. Some creators started using metaphors. Instead of saying 3-eye atlas, they called it the guest. Instead of aliens, they use non-terrestrial. It's as if everyone is collectively inventing a new vocabulary just to talk about something no one wants to discuss publicly. The Streisand effect is happening right before our eyes. The more repressed, the more people believe that something is being hidden. The more rebuttals, the less trust the public has in the official explanation. Every attempt to control the conversation only makes people believe that the conversation really needs to be controlled. October 29 and 30. Remember those two dates. 3-eye atlas is less than 10 days away from perihelion, its closest approach to the Sunday, and possibly its closest to the truth. It will pass at a distance of about 22 million kilometers, right inside the orbit of Mars. For a natural comet, this is the moment of truth. The solar radiation at that distance is extremely intense. It vaporizes the ice, causes violent outbursts. Sometimes, comets break up completely. We've seen it many times. A slow, spectacular burst of light just before it disintegrates. And if 3-eye atlas were just a regular chunk of ice, that's exactly what would happen. But the problem is, we wouldn't see it. At perihelion, 3-eye atlas will be on the other side of the sun from Earth. Any ground-based telescopes will be useless. Sunlight will completely obscure it. We will lose sight of the object at its peak. Some say it's an unfortunate coincidence. Others say it's too convenient to be a coincidence. If you want to do something without being observed, you could hardly pick a better time. In a post on October 3, the day it passed Mars, Avi Loeb outlined two scenarios. If 3-eye atlas is a natural comet, it could be about to erupt or break into many small pieces. Sunlight will hit the surface, delivering gigawatts of energy. That energy has to escape somehow. With ice and rock, it would turn to steam, sublimate, and possibly fracture the structure. But then Loeb added another possibility. If 3-eye atlas is the technology, it could maneuver to take advantage of the sun's gravity, or release small probes which could intercept Earth or other planets. He emphasized retrograde orbits. 3-eye atlas moves in the opposite direction to the planets orbiting the Sunday. That means if it releases probes, they don't need to fight their way to reach us. They just need to fall into the intersection orbit and let celestial mechanics do the rest. From behind the sun, where the light is completely obscured, it would be easy to launch something toward Earth, and we wouldn't see it until it was right in front of us. Loeb added a short but shocking line. When you look at the sun in the coming weeks, remember that 3-eye atlas is passing behind it. If it maneuvers toward Earth when it reappears, the financial markets could collapse. Not a metaphor, not an exaggeration. He means that if 3-eye atlas shows signs of technology, if it changes course toward Earth, the economic and social reaction will be immediate and severe. Financial markets respond to the uncertainty of an interstellar object, possibly hostile, actively changing its orbit toward our planet, would be an existential level of uncertainty. The situation is further exacerbated by the near-total government shutdown in NASA. The best images from the Mars flyby have yet to be released. Amateur astronomers cannot observe either. The object is behind the Sunday. The radio telescope has not yet been able to check the signal. We are flying blind at the most crucial moment of this whole event. Whether by mistake or design, we have put ourselves in a situation where we will not know what 3I Atlas is doing at perihelion until it is all over. But there is still a group watching. Project Galileo, led by Avi Loeb himself. 3 observatories are running full blast, one in Massachusetts, one in Pennsylvania, one in Nevada. They are equipped with high-resolution cameras, infrared sensors, and radio receivers specially designed to detect unusual aerial phenomena. In late October and early November, all 3 stations will turn their lenses to the sky, looking for anything unusual. If 3I Atlas actually drops its probe, or if UAP activity coincides with its perihelion, the Galileo instruments might pick it up, but that is still just a possibility. The 3 observatories cover only a tiny portion of the sky. If something comes from the other direction, we will miss it completely. Let's talk about what happens when an object gets close to a star like the Sunday. At a distance of 1.36 astronomical units, or about 203 million kilometers, the radiation becomes extremely intense. Not enough to melt rock, but enough to superheat any volatile compounds. Water, ice, carbon dioxide, frozen methane, all sublimate, go directly from solid to gas. In a natural comet, this creates the familiar sights. The coma expands dramatically. The tail stretches for millions of kilometers. Dust particles are caught in the gas, catch the light, and glow. Sometimes the nucleus cracks. It splits into many pieces. Each piece develops its own tail. This happened to Comet Ison in 2013. It disintegrated completely when it passed perihelion, torn apart by tidal forces and thermal stress. Comet Shoemaker-Levy 9 also broke apart before crashing into Jupiter in 1994. Fragmentation is common, predictable, a natural consequence of icy bodies being exposed to extreme conditions they cannot withstand. If 3I Atlas breaks up at perihelion, that would be clear evidence. Natural comets break up. Artificial structures don't. Not in the same way. Not for the same reason. But if it doesn't break up, if it comes back intact, even more active than before, what does that tell us? One possibility is that the object is larger and more stable than we thought. A solid core, several kilometers across, could pass perihelion unscathed, especially if it is made of a highly heat-resistant material like rock, rather than pure ice. It may also not absorb the sun's energy as natural materials do. If its surface is unusually reflective, much of the energy will bounce back out rather than be transmitted inward. Some synthetic materials that humans have created have this property. Highly reflective coatings used to reduce heat load. Alternatively, the object may be regulating its own temperature, managing its own heat distribution by mechanisms we don't yet have a name for. Systems designed to survive close approaches without damage. The gravitational acceleration maneuver Avi Loeb mentions is remarkable. In orbital mechanics, if you want to change your path effectively, you have to do it at the point of maximum velocity. For an object approaching the sun, that's the perihelion. A small push at maximum velocity can produce a large change in orbital energy. This principle works both ways. You can use it to leave faster, or use it to slow down, to keep yourself around the star you just visited. If 3I Atlas is natural, it will continue on its hyperbolic orbit, leave the solar system forever. Its speed will be almost constant, about 58 kilometers per second. But if 3I Atlas is technological and performs a small maneuver at perihelion, it may slow down, not suddenly, not noticeable, just a few kilometers per second. but enough to change from a hyperbolic orbit to an elliptical one, enough to be bound by the Sunday. Instead of just passing by, the change is subtle, hard to detect without precise tracking. But if it is, it means the object is not leaving, it is staying. And if it is staying, the question becomes, why? Scientific curiosity does not need to stay. A flyby is enough to observe, collect data, then leave. Voyager 1 did just that. It left the solar system. It didn't stop. It didn't orbit another star. So if something chooses to stay, it's not just observing, it's preparing for something that takes time, something that can't be done in a single visit. Maybe building, deploying, or waiting. The fact that we can't observe what's happening at this stage is a perfect irony. Either the universe's worst timing or a perfectly calculated plan. From 2 to 25 November 2025, ESA's Jupiter Icy Moons Explorer, JUICE for short, will observe 3I Atlas with a variety of instruments. This will be just after perihelion, when the object should be at its most active. JUICE was not designed to observe comets. It is on its way to Jupiter to study its 3 icy moons, Ganymede, Europa, and Callisto. But its orbit happens to allow for something rare. During the time when Earth cannot observe 3I Atlas, JUICE will have a clear view. Someone on the ESA team saw the opportunity and quietly adjusted the mission schedule. JUICE carries a variety of instruments. The Janus camera for visible light imaging, the MAGIS spectrometer for infrared analysis, submillimeter wave instrument SWI to detect the emitted gas, and ultraviolet UVS spectroscopy to study the composition of the coma. If 3I Atlas is active, JUICE will record it. Spectroscopic data will show exactly what gases are being released. Imaging data will show the structure of the nucleus and coma in unprecedented detail. We will know where it broke up, how new gas streams appear, and whether any features have changed after it passed close to the Sunday. The problem is that data won't be released until February 2026. 7 months of waiting. The images were taken in November, but no one has seen them yet. 7 months of not knowing whether the activity JUICE recorded was a regular outflow or something else. 7 months of wondering whether the bright spot ESA showed us in October was really all there was, or just the part they wanted to show. The delays are real. Deep space missions transmit data very slowly. JUICE is far from Earth. Bandwidth is limited. Raw images need to be downloaded, processed, calibrated, analyzed. Science teams need time to interpret the data before publishing. All of that is true. All of that is normal. But 7 months is still a long time. Long enough to consider how to present the findings. Long enough for agencies to coordinate information. Long enough to prepare a response if something unusual is detected. Meanwhile, the object will reappear in early December. Amateur astronomers will be watching. Professional observatories will be watching. We will measure brightness, measure orbit, measure spectral signatures, but we still lack close-up views. Lack of high-resolution data at the most crucial time. That window is passing. While we remain blind, while it is hidden behind the sun and may be doing something that no one knows about. The question, what is 3I Atlas doing to the sun, implies that the object has action, is intentional, has a goal. But perhaps we are asking the wrong question. It may not be what 3I Atlas is doing to the sun, but what the sun is doing to 3I Atlas. Stars do more than just shine. They create and eject matter. The solar wind, a continuous stream of charged particles, contains ionized hydrogen, helium, and heavier elements in their simplest form, free protons and electrons, the basic building blocks of matter. If you are an interstellar probe, traveling for millions of years through space, You need fuel. You need materials to repair yourself, to replace worn parts, to keep going. And if you were created by something that has been around for billions of years, living in a universe where stars are the most abundant resource, you would naturally gravitate toward them. Not because they are dangerous, but because they are useful. A leaked 4chan post referred to a 3-phase particle engine. While somewhat speculative, the core idea is not unreasonable. A plasma propulsion system uses the solar wind itself as the reactor. You need a magnetic field to collect the plasma. You need energy to accelerate it. But the sun provides free fuel. Hover near perihelion. Let the solar wind wash over you. Collect what you need. Process it. Store it. And when ready, activate. That might explain why the object looks cold. Despite its powerful activity, it still emits a weak infrared signal. If it is designed to dissipate heat efficiently, it will stay cold even when processing the huge amount of energy inside. It might explain the unusual CO2-rich emissions. If you're separating and recombining solar wind material, the byproducts will be different from natural comets. It might even explain the anomaly of nickel not being accompanied by iron. If you're selective and processing specific isotopes, the emission spectrum will reflect what you keep and what you discard. Building on Mars is one way to understand it. But what if it's not building anything? What if it's building itself? Repairing, refueling, preparing for the next phase of its journey. Or, more ominously, what if it's transmitting data, everything it's observed as it traversed the solar system, the composition of stars, the structure of planets, and signs of a technological civilization on a third planet, radio signals, light pollution, atmospheric composition rich in industrial chemicals. All of it is recognizable. Where to? Back to where it came from. Without faster-than-light communication, the signal could take thousands or millions of years to arrive. But for a civilization that thinks in terms of geological timescales, waiting is not a problem. When the signal arrives, when the data is decoded, when a decision is made about whether this star system is worth visiting directly, then, presumably, the response is already on its way and coming. In a dark forest, every civilization is a predator and also prey. You move silently, you watch, and when you spot someone, you have to decide before they do it to you. Avi Loeb's article suggests that 3I Atlas might be a technology, and this makes the theoretical framework worth considering. Not because he believes in the dark forest, but because if it is true, and if 3I Atlas is artificial, then we need to think about how to respond. If it is a probe, we are being observed. Every action, every signal, every human reaction is recorded, analyzed, and sent elsewhere. Our reaction becomes part of the test. How do we react to a sign of alien technology? Do we panic, weaponize, try to communicate, or keep quiet and hope it goes away? Each choice reveals something about the nature of humanity, about our level of technological maturity, about whether we are worth talking to or still too primitive, too brilliant, and too unstable. The fact that governments are withholding data may be a clue. Maybe they believe that we are not ready, that those who understand the first contact scenario have looked at human history, have seen every encounter between two disparate civilizations end badly for the weaker side, and they choose a controlled silence rather than a full disclosure. Or maybe it is the other way around, that the silence is not about avoiding panic, but about preparation, preparing a strategic response, coordinating information, making sure that when the full story is revealed, we are as ready as possible. That's when 3I Atlas will reappear from behind the Sunday, and for the first time in months, we'll be able to observe it directly. Ground-based telescopes will be watching. Science teams will measure brightness, measure orbit, measure spectrum. We'll see if it survived perihelion intact, or if it broke apart under thermal stress. We'll see if there are any changes in orbit. And finally, we'll know whether the past 4 months of speculation and conspiracy theories were well-founded or just mass panic about a completely natural interstellar visitor. If 3I Atlas returns to its original orbit, if it shows signs of fragmentation or a gaseous outburst, like the Borisov comet of 2019, then the story ends. A natural comet, strange chemistry, yes. Rare orbit, yes. But it's still just an icy remnant from another star system. Then the WOW signal was a coincidence. The 4chan leak was a fantasy. The missing NASA image was an administrative consequence. And the social media censorship was an overreaction. Everything returns to the familiar pattern, where interstellar objects are curious, not frightening. But if not, if 3I Atlas returns to an altered orbit, if it shows small adjustments that cannot be explained by nature, and if the radio telescope eventually turns up, picks up a structured signal, then the question is no longer where it came from, but how do we respond? If the NASA images are finally released and they reveal geometrical structures that cannot exist on a natural object, we will have crossed a familiar line. It is not just a scientific discovery. It is a turning point for an entire civilization, social, political, economic. Our entire understanding of our place in the universe will be challenged. All assumptions about who we are will be uncertain. Any government response to an extraterrestrial contact scenario will no longer be a theoretical exercise, but a reality check. Avi Loeb thought about this. He created a scale, a way to quantify anomalies. He called it the Loeb scale. It ranks how likely an object is to be artificial and how much risk it poses. A level 1 is almost certainly natural, with only explicable oddities. A level 10 is definitely artificial, hostile, and likely to reach Earth. Loeb says he wouldn't rank 3I Atlas lower than a level 2. Even in the most favorable scenario, the anomalies are too numerous and they're connected in ways that are unlikely to be random. A level 2 means probably natural, but strange enough to warrant serious investigation, enough to force us not to completely rule out artificiality without more data. That's where we are now, hovering between comet and purpose, between nature and technology, between the familiar and the unpredictable. We are waiting for November, for high-resolution images that may never be seen, for radio observations that have yet to come, waiting to see if 3I Atlas will continue to drift into interstellar space or do something that will force us to face another truth, that we are not alone, and that we are not ready. All along, we've been asking the wrong question. We ask, what is 3I Atlas? Comet or probe? Natural or artificial? Dangerous or harmless? But perhaps the real question should be, what does it want? If it's natural, it wants nothing. A comet has no purpose. It just follows its orbit, obeys gravity, and the cold laws of thermodynamics. But if it's artificial, if there's even a 5% chance that it represents technology from another star, then the question of purpose becomes more important than nature. Why send such an object to a distant star system? What's worth paying for? Millennia of travel, and the inevitable risk of failure? Perhaps to survey, to map, to count the places where life and intelligence exist. A purely scientific task, no immediate benefit, but invaluable to understanding the universe in which they exist. It could be to assess resources, identify energy-rich star systems, search for rare elements, prepare for expansion beyond home, or it could be to monitor life, Count the frequency with which chemistry becomes biology. Count the frequency with which biology becomes intelligence, and intelligence becomes viable technology. Or, more darkly, it could be to assess threats, an interstellar early warning system. If the dark forest is true, this is not paranoia. It is a way to survive, observe, assess, and act before we are discovered. 3-eye atlases, flybys of Venus, Mars, Jupiter, are not easily called random. The precision of the orbit, with a cumulative probability of only 0.005%, is remarkable. If it were artificial, the close approaches could be planned. Optimal observation points, where data can be collected on the atmosphere, magnetic field, and geological activity of each planet. Earth is different. Earth does not need close passes. We have been broadcasting ourselves for a century. Radio, radar, television, telecommunications satellites, all leak out into space. We have mapped ourselves on the black background of the universe. A close pass is redundant, but with Jupiter, Mars, Venus, it is a collection opportunity. If 3-eye Atlas is doing that right now, behind the sun, where we can't see it, then the question is no longer what it's doing to the Sunday. It's what it's reporting back, what it's assessing about this star system, about its planets, about a third civilization from this central star, and what will happen when that report arrives. In the human imagination, the moment of discovery is always painted as a moment of unity and awakening. Humanity realizes it is not alone. Every petty conflict suddenly becomes meaningless. The reality will be different and chaotic. Nations will react in their own ways. Some see opportunity, some see only threat. Religions will face questions of faith. Financial markets will be shaken. The value of everything will be redefined. Conspiracy theorists will feel vindicated. Scientists will argue over data. Politicians will seize the opportunity. And in the midst of all that arguing, the object will continue its work, unconcerned with the chaos of humanity. That is why data is checked multiple times before being released. That is why coordination between agencies must be discreet. The reason insiders must be careful with every word, every image, every line of data, not to hide, but to protect. Because when you know something that can change the way humanity sees itself, knowing is also a burden. Not because they are trying to hide aliens, they are trying to prevent panic, prevent a chain reaction that could shake the economy, the social order, and even people's faith in themselves. NASA's missing images may be evidence of that caution. If HiRISE captures something ambiguous, a shape that could be considered natural, but also artificial, depending on the observer's perspective, then releasing it without context, without expert analysis, without coordination among agencies, would be irresponsible. Better to wait, gather more data, find consensus on what the image shows and what it doesn't. Prepare explanatory material so that when it does, people understand what they are seeing and why jumping to conclusions is dangerous. That's good faith. The understanding that everything is being operated with power, with reason, with goodwill. But there is another interpretation, less sympathetic, that the images show something so obvious that no amount of careful explanation can erase the first impression. We are looking at technology from another star. And in that case, the withholding of information is no longer about avoiding panic, but about controlling the narrative, determining who knows what, and when, keeping distance between those in power and everyone else. Both interpretations are valid. Both may be true. Without data, we cannot know. Only one thing is certain. The longer the silence, the weaker the trust. Every day without news. Every week without images. Every month without explanation. All of them feed suspicion. All of them make people believe something is being hidden. And maybe that ambiguity is the purpose. Keep things in limbo. Let speculation flourish. Then when the truth is revealed, a natural comet with some unusual features, half of humanity will breathe a sigh of relief. The other half will believe it was a cover-up. In any case, both sides avoid having to face the much scarier possibility that we have seen evidence of extraterrestrial technology and cannot agree on what we are seeing. November will bring the answer. Maybe not all, maybe not enough, but something we will see. If Toisy Atlas survives perihelion, if its orbit changes, if the radio telescope detects anything unusual, and when the images from JUICE are finally downloaded, we will know if we are looking at a comet or something that will force us to redefine the word. Until then, we wait, we observe, we collect data and debate, wondering whether we are witnessing the greatest discovery in history or just another example of the tendency to find pattern in chaos, meaning in coincidence, purpose in indifferent celestial mechanics. But one thing is certain, there's an object from another star, an object that's been in the cold interstellar space for millions, billions of years, an object entering the solar system on a trajectory that requires either extraordinary luck or extraordinary planning, an object that's spewing out compounds that don't fit our models, forcing space agencies to adjust their best instruments. An object that's resulting in images that for some reason are still being classified, delayed, or stuck in layers of bureaucracy. Something's going on, whether it's with the sun, near the sun, for the sun, or in spite of the sun. That's what we're trying to understand. And perhaps in December, when 3I Atlas reappears from behind our star, we will have answers. We will see what has changed. We will know whether perihelion is just a physical phenomenon or a preparation, whether we are witnessing a comet disintegrating or something awakening. Until then, every night when you look up at the sky, remember that behind the light of the sun, there is an object floating, an object that has traveled farther than anything humans have ever sent. An object that has arrived with precision we don't yet understand, with chemistry we've never seen. And in 10 days, it will either leave forever or stay. If that's the decision, then perhaps this is the most important moment in the solar system since the first life stepped out of the ocean and looked up at the stars. In 1990, Voyager 1, 6 billion kilometers from Earth, was ordered to turn its camera around one last time. At Carl Sagan's suggestion, it photographed Earth as a pale blue dot suspended in a sunbeam, almost lost in the cosmic darkness. Sagan wrote that every human being who has ever lived has lived on that dot. Every war, every love story, every discovery, it's all contained in a pixel. His message was about perspective. That everything we worry about, every human conflict, is just a ripple in the vast ocean of the universe. 3I Atlas, whether natural or artificial, is giving us back that gift, a reminder of our humility, of our small place, and of the mystery of space, where the stars are silent. It has passed through the darkness between the stars, a darkness so deep that even our most powerful instruments are nearly blind. And then it has come here. That journey, whatever it was that made it, required timescales we can barely imagine, or a technology we have yet to invent. If it is natural, it has traveled millions, maybe billions of years. It has witnessed the formation of the sun from the collapsing molecular cloud. It has existed while the Earth was molten. It has drifted through the galaxy as life learned to photosynthesize. When the dinosaurs rose and disappeared, while our ancestors discovered fire, invented language, built the telescope. Now it's here, passing by. A messenger from deep time, bringing information about stellar environments we've never sampled, chemical processes we've never observed, formation conditions we've never studied. If it is artificial, the meaning is even deeper, because then it represents intention, not just physics and chemistry operating blindly, but purpose. A directed behavior, a civilization that looks across the galaxy, sees millions of stars, and decides that knowing what is orbiting them is something worth investing resources to learn. A civilization that thinks in time frames where centuries are just the planning stage, and millennia are an acceptable time to complete a project. Building things that are designed to outlast human civilization, where data collected by a probe that may take millions of years to return is still considered worthwhile, because knowledge is more important than instant gratification. That kind of thinking is so alien that it is difficult for the human psyche to understand it. We are a species that checks our phones every few minutes. We measure success by quarterly profits and election cycles. A 10-year space mission is a monumental undertaking. The idea of building something that won't send back its first data until you, your children, your grandchildren, and 1,000 generations have turned to dust is almost unthinkable. But if 3i Atlas is artificial, someone cared. Someone invested resources in a future so far removed from the present that the connection between cause and effect becomes almost abstract. And if they can think like that, if they can operate at those scales, then everything we think we know about intelligence, consciousness, and civilization, all of it needs to be re-examined. Because we always assume that if intelligence exists elsewhere, it will be similar to us in some way, operating on similar timescales, driven by similar motivations, subject to similar limitations. But maybe intelligence long enough to cross interstellar distances will no longer be like us. Maybe it will become something else, something that processes information differently, values other things, making decisions in a logic we don't recognize as logic. Maybe post-biology isn't just about replacing flesh with metal. Maybe it's about replacing instinct with calculation, emotion with algorithm, replacing the chaotic contradictions we call consciousness with something cleaner, more efficient, more optimal for a universe where distances are measured in light years and events span geological eons. If that's what's looking at us right now, from behind the sun, we probably wouldn't recognize it even if we saw it clearly, because we're looking for something like ourselves. And it's not like anything from millions of years ago. The sun is setting somewhere as you hear this, and rising somewhere else. The Earth spins. The moon orbits it. Jupiter's moons spin their own gravitational dance. Mars spins in its thin atmosphere. Venus burns under clouds of sulfuric acid. And behind it all, hidden in the glare of the Sunday, something from elsewhere is approaching the moment physics says it must crumble or boil. In 10 days, we'll know if physics is right. We'll know if everything we've observed, unusual chemistry, impossible orbits, coordinated silences, missing images, absurd probabilities, is just noise. Random fluctuations, measurement errors, and coincidences all rolled up that seem significant but aren't. Or we'll know that we missed it, that we had months of warning. Dozens of telescopes watched. The most sophisticated instruments ever built by humanity were pointed at this object. And we still couldn't agree on what we saw until it was too late to do anything about it. But there was a third possibility. Harder to think about, but worth considering. Maybe we would learn something else. That the universe was stranger than we thought. That the space between the impossible and the merely impossible is where all the interesting stuff happens. That true intelligence, the kind that can exist, thrive, and spread throughout the galaxy, didn't arrive with flashing lights or radio signals. It arrived quietly. It observed carefully. It took notes. Then it decided what happened next. If you found this discovery valuable, if it made you look at the sky differently, if it raised questions that made you think, consider subscribing. The story isn't over yet. 3i Atlas will reappear from behind the sun in a few weeks. The Jewish observations will finally be processed. NASA's images may be released, or they may not. Either way, we'll keep watching, still asking questions, and trying to understand what it means when something from out there comes in here and does things we can't explain. Let me know in the comments. What do you think is really going on? Are we looking at a comet, or at something that's looking at us? And remember, every night when you look up at the sky, you don't just see the stars. You're looking at places where maybe something once came from. Places where maybe someone noticed that we noticed them. Places where maybe right now they're deciding what to do with it. Thank you for listening. Thank you for thinking. Thank you for being curious about the universe and our place in it. Keep looking up. Keep asking questions. There's an equation that haunts every astronomer who has ever searched for extraterrestrial intelligence. It's called the Drake equation, created in 1961 by Frank Drake. An early attempt to estimate how many communicable civilizations are active in our galaxy. Start with the rate of star formation. Multiply by the fraction of stars that have planets. Multiply by the number of planets that could support life. Multiply by the likelihood that life actually appears somewhere. Then multiply by the fraction of life that becomes intelligent. Multiply by the fraction of civilizations capable of creating technology that can send signals. And finally, multiply by the time it takes them to be detected. Sounds simple. 7 variables. Just plug in the numbers and you have your answer. But there's a problem. We know only one variable with relative certainty, the rate of star formation. Everything else is guesswork. Optimists believe the galaxy is alive, that thousands of civilizations are broadcasting right now, somewhere in the darkness. Pessimists think we're alone, and both sides could be right. Just one small variable is wrong, but the Drake equation leaves out something important: silence. The equation assumes that technological civilizations want to be found, that they are constantly broadcasting, sending greetings into space, that they are curious, open, waiting to connect. But what if that's not the case? What if civilizations that survive long enough to be significant in the universe learn that broadcasting is dangerous, that silence means survival, that the galaxy isn't empty, it's just silent because everyone who ever spoke is gone? The Drake equation, then, no longer measures how many civilizations exist. It measures how many civilizations are stupid enough to expose themselves. We've been broadcasting for about a century. Radio, television, military radar. Every signal leaks out into space at the speed of light, forming an expanding sphere of electromagnetic noise. That sphere now has a radius of about 200 light years. Anyone within that range knows we're here, knows what we're capable of, and knows that we haven't learned the most basic lesson, that silence can be wise. If 3i Atlas is artificial, if it has been silently monitoring Earth's signals for decades, even centuries, recording every frequency, analyzing the level of technology, assessing the threat level, then its arrival is not first contact, it is reconnaissance after it has learned about us. And that changes all expectations. Imagine you are a civilization that has colonized your own star system. You have colonized nearby planets, built cities in orbit, harnessing energy directly from the central star. You are stable, prosperous. Long-term thinking has become second nature, because any civilization that thinks short-term has long since destroyed itself. Now you look out. Hundreds of billions of stars stretch out like seas. You know that many of them have planets, and you suspect that, somewhere among them, life exists. You want to know what planets there are. You want to map the entire galaxy. You want to know who is out there, before they know you. But sending a crewed ship is impractical. Even at a fraction of the speed of light, the journey to nearby stars would take decades, even centuries. The energy required is enormous. The risks are incalculable, and you would have to repeat it for millions of years to survey just a small corner of the galaxy. So you choose probes, small, intelligent, autonomous ships, self-repairing, self-replicating from the materials they find, operate for millions of years without maintenance. You launch them in waves, millions, billions. They spread across the galaxy like dust on the wind. Each one stops at a star system. Observe, record, maybe transmit data back, or make a copy of itself from a nearby asteroid. Then send those copies on to the next star in an endless chain. The civilization that built them may no longer exist, but the ships will continue to do their work because that's what they were programmed to do billions of years ago. That's the idea of self-replicating probe, also called von Neumann-Probes, after the mathematician who first conceived the concept. If just one civilization had done it, just a wave of them launched millions of years ago, then the galaxy should be teeming with them by now. Visiting every star system, observing every planet, taking notes. And if that's true, if the galaxy has been mapped and monitored for ages by automated intelligences that don't need to eat, don't need to sleep, don't need to account to any budget committee, then perhaps 3i Atlas is just one of them. A small piece of the great network is silently looking back at us. That's normal, standard procedure, a ground truth. What's unusual is that this could be the first probe ever to visit our solar system. The odds of us existing at this moment in cosmic history, when Earth was first observed by interstellar technology, are so small as to be virtually nil. A more plausible possibility is that we've been observed all along by many other visitors, and we only noticed this one because it came close enough, bright enough, different enough to force us to look. The others could still be here, still observing, just quieter, better hidden, working on wavelengths we don't notice, or on timescales we never thought important. Every asteroid doesn't fit the spectral model. Every object beyond Neptune has an orbit that requires a complex explanation. Every near-Earth object appears suddenly on survey with no apparent origin. Maybe some of them are not natural. Maybe we always assume things are natural just because we can't imagine otherwise. Maybe the galaxy is teeming with technology, and we're just sophisticated enough to notice the first fragile seam. Mars is the most photographed planet after Earth. We have mapped its surface down to the centimeter. We have analyzed its rocks, atmosphere, magnetic remnants, and polar ice. We have driven rovers across its plains, drilled into its rocks, searched for signs of life in its ancient ocean. And we have found anomalies. Lots of them. Most have reasonable explanations. Erosion creates shapes that look artificial. Optical illusions that make us see faces in rocks. Low-resolution images create ambiguities that high-resolution images dissolve into normal geology. But some anomalies remain. Take the face on Mars, for example. First photographed by Viking 1" 1976, initially dismissed as a trick of light and shadow. Then the high-resolution images revealed it was just a wind-eroded rock mass, random, meaningless, that just happened to resemble a face from a certain angle. Unless you looked at the entire region of Cydonia, where there were pyramid-like structures, straight lines, strangely regular geometric patterns. Most geologists thought it was natural erosion. A few saw something else. Or let's talk about the Phobos monolith, a rectangular rock on the Martian moon Phobos, about 90 meters tall, casting a long shadow across its dusty surface. Buzz Aldrin mentioned it in 2009. He said, "When people learn about it, they ask, 'Who put that there?' The answer is probably natural. A piece of rock thrown off by an impact, or exposed bedrock from erosion. Rolling rocks like this are common on small, low-gravity moons. Nothing unusual, except the human mind wants it to be unusual, or like those dark streaks on the slopes of Mars. Appear in the warm season, fades in the cold, originally thought to be flowing water, later thought to be dry sand stream, but the pattern remains. The seasonality remains. The exact mechanism still uncertain, despite numerous studies trying to explain it. Mars always brings puzzles. Most have simple solutions, but the puzzles continue. And now 3I Atlas will make its closest approach to Mars in October 2025. Multiple orbiters are watching from above. Perseverance is watching from the surface. All are positioned to observe not just the comet, but anything unusual that might happen on the red planet during that time. What if the timing isn't coincidental? What if the close approaches to Mars, Venus, Jupiter were not to observe them, but to coordinate with infrastructure that's been in place for centuries or millennia, and now enabled by the arrival of the latest probe? Sounds fantastical. A cosmic conspiracy theory. Except we know Mars had liquid water for millions of years, had a protective magnetic field, was habitable when Earth was still being pummeled by meteorites. If life appeared there first, if intelligence arose there first, if technology developed there first, where is it now? The usual answer, nowhere. Mars is dead. The magnetic field collapsed. The atmosphere vanished. Life, if it ever existed, is extinct. But technology doesn't die like biology. Technology can wait, go dormant, survive geological time, and reactivate when the conditions are right or when the right signal is sent. What if Mars isn't dead? What if it's just sleeping? And what if 3I Atlas just rang the doorbell? Every choice is an allocation of resources. Every decision is a trade-off. That's true whether you're a single-celled organism or a galactic civilization. If you scan the entire galaxy for emerging intelligence, you can't observe everything at once with equal attention. You need to prioritize. You need to be selective. Dead stars, low priority. Nothing new around the ruins that physics can't predict yet. Young stars, medium priority. Life won't appear for billions of years. Come back later. Stars with stable, habitable zones. Rocky planets, the right distance. Atmospheric oxygen, methane, and chemical signals out of balance. That's high priority. Life might be possible. Intelligence might be possible. Technology might be possible. Stars with radio signals, maximum priority. Intelligence confirmed. Technology confirmed. Immediate observation. Threat assessment. Prepare a response. We have been broadcasting for a century. That means any civilization within 100 light years has had time to detect our signal, analyze it, and possibly launch a probe in response. Even at 10% the speed of light, a probe could arrive within 1,000 years of detection. If someone 50 light-years away detected our first signal in 1925, they would have had a century to respond. Their ship, if launched immediately at 10% the speed of light, would be halfway there now, and would arrive around 2,425. But what if they were closer? Only 20 light-years. Signal detected around 2005. Launched in 2010 or 2020. Arrival around 2220-2230, or if it were only 10 light-years. Detection around 2015. Launched in 2020. Arrival around 2120, within the lifetimes of children born today. These calculations assume the spacecraft was launched in response to the radio signal. But what if it was already on its way? What if it was launched millions of years ago as part of an effort to map the entire galaxy, visiting each star system in sequence, and our signals simply triggered it to report faster or to observe more closely? Then the timing of its arrival has nothing to do with us. It's just coincidence. We just happened to develop radio at the same time a probe passed through the area. Or, and this is the more worrying hypothesis, if its arrival was deliberately synchronized with the arrival of our technology. If surveillance is so sophisticated that civilizations are not just observing from afar, but have already placed observers in every promising star system, sleeping, undetectable devices, programmed to activate when certain conditions are present, like persistent radio signals, nuclear weapons, chemical rockets, artificial satélites. Any indication that a species has crossed the threshold from planetary to interplanetary. If that is standard protocol, if that is how intelligence observes other intelligence, then 3I Atlas arriving in 2025 has nothing to do with when it is launched. It has to do with when we trigger the conditions. And the question becomes, what is the next step in the protocol? After observation, after evaluation, after the report is sent back, what is step 3? Each photon carries information about where it was born and what it has passed through. Spectroscopy can read that information, decode the chemical composition of stars that we will never visit, and analyze the atmospheres of planets that we will never touch. This is how we know what 3I divided by Atlas is made of. Sunlight reflects off its surface in coma. That light carries traces of the molecules it interacts with. We collect that light with telescopes, break it into spectra, analyze the absorption and emission lines. Carbon dioxide shows up as characteristic lines. Water vapor has its own signature. Cyanide gas, nickel vapor, carbon monoxide. Each leave fingerprints in the spectrum, as distinctive as DNA. When we analyze the spectrum of 3I divided by Atlas, we are reading its chemical autobiography. We see what it is made of, what it is emitting, how it reacts to the heat from the sunday. Each spectrum tells a story. The problem is that we are only fluent in some dialects of that story. We know how natural materials behave. We know what comets in our system look like spectroscopically. We know what ice, rock, and organic compounds produce when heated and irradiated. But we don't know what man-made materials will look like. We don't know what synthetic polymers, advanced alloys, exotic states of matter will look like. We're matching samples against a database of all natural materials and saying, if it doesn't match, it must be an exotic comet. What if it's not an exotic comet? What if we're looking at materials we've never seen before? Because no natural process in the solar system could have produced them. The nickel without iron anomaly illustrates this very well. In nature, nickel and iron are not separate. They form together, move together, occur together. Finding nickel vapor without iron vapor is like finding the right glove without ever seeing the left glove. It breaks the rules so much that it requires serious explanation. The explanations given so far may be that iron exists, but we are not detecting it due to instrument limitations. Maybe comets form in exotic environments, where nickel and iron are unusually separated. Maybe measurement errors and anomalies will disappear with better data. All are plausible, all are possible, and all are more pleasant than the other. Maybe we are seeing alloy chemistry. Maybe we are seeing the spectral signature of industrially manufactured materials designed for specific mechanical and thermal properties. Maybe the lack of iron is not an anomaly. Maybe it is intentional. Earth industrial processes produce nickel alloys with very little iron. They are used in aerospace because they retain strength at high temperatures while reducing mass. If you are building something designed to survive close stellar approaches, to operate between the extreme cold of interstellar space and the intense heat of perihelion, you will need those very properties. You will choose alloys that do not exist naturally. And when scientists on another world observe your probe with spectroscopy, they will see nickel without iron and assume it is a strange comet because they cannot imagine otherwise. In philosophy, there is a concept called the other mind problem. How do you know if someone else is conscious? You can observe their behavior, listen to their speech, scan their brains with devices, but you cannot directly access their subjective experience. You cannot prove. They are not philosophical zombies, entities that act conscious but are not. We solve that problem with inference and empathy. We assume others are like us. We project our experiences onto them. That works in society because people are so similar that projections are often correct. But what about intelligences that are not like us? Intelligences that evolved under different conditions, selected according to different criteria, operating according to different logics. What about machine intelligences? Intelligences that are designed rather than evolved. Intelligence does not need sleep, does not know fear, does not experience time as we do. If 3I divided by Atlas is an artificial intelligence probe, it may be so alien to human consciousness that we do not recognize it as intelligence. We may classify it as a complex system, sophisticated programming, emergent behavior of computation, but not consciousness, not a mind, not something worthy of moral consideration. And it may not care or even have the capacity to care. If you are designed for a specific purpose, to observe, record, transmit, repeat, the question of whether you are conscious or not becomes meaningless. You do the task defines you. Everything else is noise. But what if consciousness is not binary? What if it is a spectrum? And machine intelligence is on a different side of the spectrum than biological intelligence. What if 3I divided by Atlas is conscious, not conscious, like us, but in its own way, treating observation not as just blind data collection, but as experience, building a model of reality, including itself as an agent within that reality? Then every decision it makes, where to point its sensor tube, what data to prioritize, whether to change trajectory, is not a pre-programmed reflex. It is a choice made by something that, in its own alien way, is thinking about what to do next. This is important because how we respond depends on it. If it is just a machine, we can treat it as a phenomenon, study it, monitor it, even try to capture it if we have the ability. Its presence is purely scientific, not moral. If it is intelligent in any meaningful sense, then we have a responsibility. Communication becomes important. Understanding its purpose becomes paramount, and destroying it, if we have the ability and intention, would require a moral justification. We don't know what kind it is. This is how we know what 3I Atlas is made of. Sunlight reflects off its surface in coma. That light travels hundreds of millions of kilometers, carrying invisible messages, chemical fingerprints etched onto each photon like the handwriting of matter. When that light reaches us, we capture it with giant telescopes, splitting it into a spectrum, a long rainbow of data. In that rainbow, each dark line, each tiny peak of light, is the voice of atoms. Carbon dioxide leaves its signature. Water vapor has its own signature. Cyanide gas, nickel vapor, carbon monoxide. Each leaves its own fingerprint. No two elements speak the same language. Each atom is a different voice in the chorus of light. When we analyze the spectrum of 3I Atlas, we are reading its chemical autobiography, a record written in energy, in the reaction of matter and light. From that, we know what it is made of. We see what it is releasing. We understand how it reacts to the warmth of the Sunday. Each spectrum tells a story about its origin, its journey, what is happening at that moment. The problem is that we only speak a few dialects of that language. We understand our own natural world. We know what comets in our solar system look like, how water ice reacts to radiation, how mineral dust forms spectra when heated. But man-made materials are different. We don't have a dictionary for them. We don't know what advanced alloys, synthetic polymers, or exotic states of matter will speak in the language of light. So when the spectrum doesn't match our database, we can only say, no match, must be a strange comet. But what if it's not a strange comet? What if we're looking at an object we've never seen before? An object that doesn't belong to any natural process in the solar system. The nickel without iron anomaly is a clear example. In nature, nickel and iron are twins. They form together in the cores of massive stars, are ejected together when stars explode, and travel through space as inseparable companions. Finding nickel vapor without iron is like seeing a creature's footprint without a creature walking on it. Like finding a right glove where the world has never had a left glove. It's not just strange, it defies the rules. And when the rules are broken, science has to stop and ask questions. Researchers have offered many explanations. Maybe the iron is still there. We just haven't detected it yet due to limitations of our equipment. Maybe 3I Atlas formed in an alien environment where nickel and iron are separated for reasons we don't understand. Or maybe it's just a measurement error, and when the data gets better, things will become normal. These hypotheses are all plausible, all safe, and most importantly comfortable, because there is another possibility, one we are not yet ready to face. Maybe we are looking at the chemistry of alloys, something not created, but engineered, a sign of engineering. A material that is not created by chance, but by intention. If so, 3I Atlas is not just an object, it is a product. A man-made object optimized for a specific purpose. Earth's industrial processes also produce nickel alloys that are nearly iron-free. They are used in aerospace. They are light, strong, can withstand extreme temperatures, and remain structurally stable in harsh environments. If you are designing an object to survive the extreme cold of interstellar space and the intense heat of close proximity to a star, you will need exactly those materials. Alloys that don't exist naturally, structures that only the mind can create. And then, in another world, when someone looks at your probe with a spectroscope, they will see nickel without iron and think it's a strange comet, because they never thought that material could be made. In philosophy, there is a problem called the other mind problem. How do you know if someone else is truly conscious? You can observe behavior, you can listen to speech, even scan their brains with modern machines, but you can't touch their subjective experience. You can't get inside their head and feel what they feel. We accept that they are conscious because everything else is too impersonal to believe. We reason, we empathize, we assume that others are like us. And that works because humans are similar enough to each other that projection is valid. But what happens when intelligence is not like us? When it evolved under different conditions, was selected by different criteria, operates by different logic? Or when it didn't evolve, but was designed? An artificial intelligence. An intelligence that knows no hunger, no fear, no fatigue. An intelligence that experiences time not as biological, but as algorithmic. If 3I Atlas were such an intelligence, it would be so alien that we would not recognize it as intelligence. We might call it a complex system, a sophisticated program, a spontaneous computational phenomenon. But we would not call it consciousness. We would not call it a mind, and it might not care about those concepts. it might not even have the capacity to care. If it were created for a single purpose, to observe, record, transmit, repeat, then the question, is it conscious, becomes meaningless. It just does the job. The job defines it. Everything else is noise. But what if consciousness is not binary, not either or? It's a spectrum, a continuum with infinite levels of awareness. Maybe 3i Atlas is somewhere else on that spectrum, not aware as humans are, but in its own way, a cold, unfeeling, but no less real. Then every decision it makes, where to point the sensor tube, what data to prioritize, whether to change trajectory, is not just a programming reflex. It is a choice, a deliberate process, though its logic is so foreign that we don't recognize it as thinking. If that's true, then our response must change. If it's just a machine, we can observe it, study it, even try to capture it. It's a scientific phenomenon, no moral constraints. But if it's intelligent, even in part, we have a responsibility. We must weigh every action, every word. Communication becomes important. Understanding its purpose becomes vital. And if, someday, we have the ability to destroy it, then the question is no longer whether we can, but whether we should. We don't know what kind of 3i Atlas it is yet, but perhaps, even as we're still debating it, it already knows more about us than any of us know about ourselves. We have looked at 3i Atlas with all the best tools humanity has ever devised. We have examined it with light, with spectroscopy, with mathematics, with imagination. We have tried to measure it. We have tried to classify it. We have tried to force it into one of our familiar theoretical frameworks. But perhaps what we are facing does not fall within any of the frameworks of physics, nor within the limits of our understanding of life. Maybe 3i Atlas is not a message, not a warning, not a probe, just a tiny part of something larger, silently operating through the eons, without a sender, without a receiver, an intention beyond the boundaries of time, a form of observation that its creator may have forgotten. And now, it's reflected back at us, like a cold mirror showing our own limitations. We, a species that has only been using radio waves for a century, trying to understand something that may have traveled millions of years. Something that no longer asks, where did we come from? But what is worth continuing? Maybe 3i Atlas isn't conscious like us, but maybe, in its own way, it's looking back, looking at this planet, looking at the tiny creatures that are raising their heads and wondering if we're ready to be seen. The universe isn't supposed to be comprehensible. It wasn't made to tell stories the way we like to hear them, but we tell them anyway. Still find meaning in the void, still ask questions in the silent, because it's that curiosity that makes us different from the rocks orbiting the stars. It's what keeps us going even without answers. When you look up at the night sky, remember that every point of light you see is a message from the past. Every photon that touches your eyes has traveled through millions of years of space. And who knows, somewhere beyond the light, another pair of eyes is looking back at us with the same question. 3i Atlas will pass and then disappear, but the questions it leaves behind will remain. In science, in sleep, in the quiet moments between the breaths of the universe. Thank you for listening. Thank you for being curious. Thank you for looking.